Well, hello everyone. Welcome to another OpenStack online meetup. I believe this is our fifth for the month of August. Raphael and I are very busy getting a lot of different people to present, and we're really excited. We have something rather interesting new. The CloudSoft team up in Scotland, we've been working, and we've known these guys for some time. They're doing some interesting stuff, and they are part of the Brooklyn project, a part of Apache, and now they have something called Clocker. And of course, you know it's going to associate with Docker, so we couldn't resist, so we had to get them. So with us today is Andrew Kennedy, who is the creator of Clocker, Andrea Turley, who's a co-creator of Clocker, and we're working to get Dave Nielsen on as well, and many people know Dave from CloudCamp and everything. So I'm just going to simply turn this over to the CloudSoft guys with Clocker and go mute. And again, if you have questions, we will be watching the standard IRC channel that we always talk about, OpenStack Community, and then we'll pass those questions on to the speakers, and they can either take them as they come in or answer them later. So I will be quiet and let the Clocker team take over.
Okay, hi. So this presentation is about Clocker and OpenStack. That's better. There's a bit of feedback. Sorry. So the presentation is about Clocker and OpenStack. I'm Andrew Kennedy, and I work for a company called CloudSoft here in Edinburgh. And as Stephen said, we produce an open source product called Brooklyn, which is a cloud management software recently open sourced in the Apache project. With me is Andrea, another colleague. He's a developer here, and he's also works in the same product. And like I said, hopefully Dave will be joining us. So what this talk is about is we're going to talk about Docker and how that fits in with the OpenStack ecosystem, and how Brooklyn can help with that, and not just Brooklyn, but the Clocker project, and hopefully show a demo with the campsite application, which is an application that Dave has been working on to host his Cloud Camp conferences. So, well, initially Dave was going to do an introduction about Docker, just explaining a little bit. So I'm not sure how familiar people are with Docker. It's been gaining in popularity a lot over the past year. It's a project started by .cloud, who originally wrote Docker just as an internal project to manage Linux containers on LXC, and that's now become their sole purpose. That's all they do. They've divested themselves of .cloud, so now they're just wholly developing Docker as a container management system, and around it there has been a huge build-up of ancillary software projects, a huge ecosystem of tools, utilities, management systems, things like that, just to help help simplify the Docker experience. And sites like Docker Hub, Key.io, things like that, that provide extra features as well for the Docker ecosystem. So Docker itself, now, being as this is an OpenStack meetup, I'm sure you're all familiar with virtual machines, and in fact the diagram at the left here shows the kind of typical setup when you're running a bunch of apps using a standard cloud environment like OpenStack. So you have the base operating system. Running on that will be a hypervisor, and then your applications, the 4 apps here, A to D, are all running. They each have their own guest OS, and then the libraries they need and the application themselves. So you can see appd there in bold has got a whole operating system overhead. It's got the libraries and the app itself. So Docker it's very similar to this, but instead of running a hypervisor and duplicating the guest OS multiple times, the diagram on the right here, we've got the operating system, Docker engine running on top of that, just as a single application, and it's the Docker engine that handles the segmentation of the apps into containers. So you've got app A to D there, and again, it's much more lightweight. The boxes are probably scaled a bit wrong to give you the right idea, but the guest OS takes up an awful lot of resources there. So what Docker's doing, it's you've got no hypervisor, no guest OS running, so there should be a lot more room at the top. You can fit more containers in. So these containers, the term that popularized for these now, Martin Fowler wrote a recent article about this, microservices. So instead of big monolithic virtual machines running complicated apps, what Docker containers are promoting is this microservice concept where you have a very minimal configuration, just a single service. In the Docker world, this is we use Docker files to configure that. It's a configuration mechanism. It describes the service itself, the things it needs, whether that's volumes, data, packages that need to be installed, files you need to put various places, and these are composable. So one can take a Docker file describing a particular microservice and compose on top of that another image with, say, a file system that you need, and that'll be unioned with that to give you, the components of both Docker file containers. So we want to, this is basically talking about Docker on a single machine. What we'd like to do is use Docker in the cloud. So to begin with something like OpenStack, it's not particularly different. Linux is Linux, so you've got an Ubuntu operating system, and it's going to be the same whether it's running on your laptop or on a VM provisioned by OpenStack. But to get Docker running in the cloud on OpenStack, there is a manual process that you've got to go through, not just Docker, but to get something useful, an application running on Docker. So we need credentials for OpenStack, we need our identity, we need our password to log in, we need SSH keys that give us permission to access virtual machines in the cloud, we need some operating system image for the underlying OS that will run, some, like I said, Ubuntu 12, Ubuntu 14 image that works. We choose a hardware ID, small, medium, large, that is suitable. We then need to create that compute resource, download Docker and install it, configure it appropriately, which is pretty simple, I admit, in the case of Docker, and then take our application and generate these Docker files for the services that we want to run. So this process, there's a fair number of projects out there, that try and automate this process, and say the one we're going to be talking about today is Clocker. So as a bit of background to Clocker, first, it's based on the Brooklyn project. So that's it's now an Apache project. It's open source. It's part of the Apache incubator for the past couple of months, not very long, and it's a cloud application management platform based on autonomic computing concepts. So the idea that we can do things automatically to deployed applications, automatically manage them without user intervention, do useful things to them. It relies on YAML blueprint files to describe applications. That's YAML blueprints. They're actually part of the OASIS CAMP standard, which is Cloud Application Management Platform. I think it's Platform CAMP standard, which describes how an application is put together, and it's built. These blueprints are built from services, which we call entities in Brooklyn, the configuration for those services, and then once the services are deployed and up and running, the Brooklyn platform provides attributes or sensor data on those running entities, so you can see various bits of information about them. You can look at a web application and see requests per second, or the number of errors, or location of a log file, information like that, the host it's deployed to, the port number it's listening on, that kind of thing. And finally, the entities have effectors, which basically let you do things to the entities, start them, stop them, deploy a WAR file to a web app, run a particular Docker command, for instance, Docker PS, that sort of thing. Resize a cluster, that sort of thing. So Brooklyn is it's a platform, a control plane for managing these applications in the cloud that are described by these blueprints. And in fact, Cocker is essentially, it's just another Brooklyn blueprint with a bit of extra intelligence in there. So it's providing for us some infrastructure, which is the parent entity. It's made up of Brooklyn entities, just like any other Brooklyn application. So the parent entity is a Cocker infrastructure, which manages some Apache JCloud supported cloud. Obviously, to run Docker, we need some place to get the virtual machines that we run Docker on. So that will run on any Apache JCloud supported cloud, so long as you provide it the right credentials and whatever ancillary configuration is required. Underneath that, as children of that infrastructure entity, we have Docker hosts, and these are entities that represent each running Docker engine. Docker engine rather than service, I think it's called. So these Docker hosts control the download, the install, all those manual steps that I talked about earlier are all encapsulated in the startup of these Docker host entities. Once it's up and running, you have a deployed and installed Docker running on a VM. And the additional thing that this does is part of JCloud's Labs 1.8.0, so it's the latest release of JClouds, and that's what Andrea is here for. He'll be able to answer questions about this later. There's in the same way that JClouds has drivers for various different cloud APIs and environments, there's a driver for Docker. Docker as well as CLI, we've got a RESTful API. So JClouds can talk to that REST API and carry out operations on that. So normally it would be providing virtual machines. In this case, we're taking the Docker host and we're providing virtual containers instead, with an SSH daemon running, because that's the way JClouds and Brooklyn manage software remotely. They SSH in using whatever SSH key and go and manipulate, just execute a series of commands to set the host up, or in this case, set the container up the way you want. And in the same way that the infrastructure has a group of Docker hosts, each Docker host has got a group of Docker containers as children. And these Docker containers are what have been created using this JClouds mechanism. And the Docker container entities are essentially, well, they're the containers for whatever application you want to run on Cocker. So to containerize an app, you run it on Cocker and entities get deployed to Docker containers that are provisioned for you. If that seems a bit complicated, there's a diagram here. So what we've got, we have Docker infrastructure at the top, as you can see, and inside that infrastructure, multiple Docker hosts. underneath those Docker hosts, we have even more Docker containers. You can have many containers per host and a series of hosts per Docker infrastructure. You can see those map up to the Docker infrastructure, maps to a Docker location, and that Docker location is somewhere I can now deploy an application to. The location provisions virtual machines for the Docker hosts, and at the very bottom, each Docker container is running some particular service doing something useful for us. So what I'd like to show you now, if we can flip over to, hopefully, oh, sorry. All right, okay. So what we've got here is HP Docker Cloud. This is the Brooklyn console. I've deployed Clocker to this, so what I did, this is the way you deploy applications in Brooklyn. It's application catalog. Here's the Docker Cloud. There's various locations. I selected an HP Helion, that's an OpenStack location. Oh. Sorry, something wrong. Yeah. Okay, so yeah, locations. I selected the HP location, configured it, gave it a name, set up the Docker version, and deployed that. That gave me this tree of entities. We can see a Docker host. You can see the sensors I was talking about. The host is a particular address and a name, various properties there. It's retrieving the memory, the load average, and so on. So I can deploy to that applications. So for instance, Tomcat, I can deploy that to this HP Docker Cloud. If I hit finish, you can see I now have a Tomcat application here. And this Tomcat server, if we have a look at activity, what's it doing? It is provisioning something in the Docker infrastructure. And what this is going to do, you can see the Docker host currently is an empty set of containers. Once it's provisioned, we'll have it takes its time. I think that's my network connection. So just see here, activity. Okay. Well, okay, we can leave that and come back and watch this once it's actually finished deploying. I mean, it's not particularly interesting watching applications being created and containers being set up. So we can leave that for the moment. Okay, so while that's running, I'll go on to talk about some of the features of Clocker that we get over and above Docker. So you saw there that with the Docker Cloud, we had 2 Docker hosts, and we deployed an application to that Docker Cloud, and that creates, well, this is the demand side of Clocker. It's asking for something new. It's demanding resources. So in this case, we were creating a new container, but there are other ways that we can demand new resources. We could be resizing an existing cluster. Perhaps we've got a Cassandra cluster running. We could have a web app cluster that has too much load, and an auto-scaling policy attached to it has decided I need to increase the number of nodes in this cluster. So Brooklyn, and through Brooklyn, Clocker in various ways can decide that it needs more resources. Clocker can then choose to supply these resources in various ways. And with Docker, essentially you would choose a host and go, Docker build and create a new container. What Clocker is able to do is manage different strategies for placing containers across these multiple hosts. So there are some pretty obvious ones, the depth or breadth first. So we can say that each container has a maximum size of, each host, sorry, has a maximum size of, say, 5 or 6 containers. So a depth first strategy would simply create new containers in a host until we reach that particular maximum, then move on to the next one. This way we're conserving the amount of new virtual machines that get created. We could want to maximize the utilization of a pool of machines, so breadth first policies where we round robin across those machines. Host A gets a container, then B, then C, then back to A, and so on. And again, perhaps there can be some limit there, so if they all fill up, we provision a new host. We can have affinity rules attached to containers as they're created. So perhaps my Tomcat service wants to be deployed next to a Solar or Lucene index. Perhaps my Cassandra cluster node doesn't want to be in the same place as my Nginx load balancer for the web app that it's backing. So these affinity rules, we can specify affinity and anti-affinity across different entities and use that to generate intelligent placement of containers across multiple Docker hosts. This is something new that we get to do because we have Brooklyn doing the controlling of all of the Docker engines. And we can also do smart resource allocation. So each host could have a certain number of CPU shares, and if we allocate a particular entity, we have 10 shares per CPU, one entity takes 5, we search for a host that has 5 available CPU shares. Or we search for a machine with enough available memory or a low enough load average, so we're not looking for overly stressed resources. Lots of ways that we can do intelligent things now that we have this amount of control. And of course, the placement strategy is also, it's a Java class, so you could write your own and write a simple predicate that gets applied to locations and define your own custom strategies. And Clocker, really, it's using exactly the same. You're not faced with the problem, or at least initially, that one has with Docker, where you have to go and configure Docker files for each service in your application. Because Clocker is written using Brooklyn, we get to use the same camp blueprints that we used with Brooklyn deploying to native OpenStack and virtual machines, or the same Java blueprints. We can use these pretty much unchanged. Of course, we can also add Docker specific configurations. So the affinity rules I was talking about, those obviously they don't exist in OpenStack natively, so we can add those to a blueprint. We could customize an entity, say it needs a particular Docker file to customize the container or to use a particular container image ID, or again the CPU and memory shares I was talking about. Perhaps we want to configure a particular volume to be mounted for this entity from the host virtual machine. So although we can use the blueprints unchanged, there's plenty of scope for configuring Docker specifics and getting really quite complex application blueprints doing some pretty intelligent things with your application when it gets deployed. Okay, so I'm going to flip back here. Oops. Okay, so yeah, we can see now we've got our Tomcat server. Here it's green, it's running. If I look at the sensors, I can see all the Java information. We've retrieved that with JMX. And essentially this is to a user, it's not possible to determine, is this running on a VM or is it running on Docker? We're getting exactly the same information. But if we look, expand this out, at Docker Cloud, we can see there's a Docker container running. That Docker container has an entity, it's our Tomcat server. We can see there the Tomcat application. So I can, in fact, click on this and actually move to the container, have a look, information. This container is running in a particular Docker host, and effectors, I can then go and we can even run commands on that host. If I run docker ps, we can see the SSHD, there's other things I was running, you can see about an hour ago. This one up 3 minutes here. At the top, this is the container that I just started for that Tomcat app. So we can access right into, I could then run docker inspect with that container ID and so on. So we have full access to the Docker hosts, and we can run pretty much any application we want here. The Tomcat app there was nothing special about it. It would run equally well on OpenStack itself natively. Okay. Okay, so campsite. This is, again, something that Dave was going to talk about, but I don't think Dave is here yet. So, well, I can describe it briefly. Campsite as an application, it's available on Dave's GitHub repo, and obviously I'll give the link for that at the end. And of course, I'll give links for Brooklyn and Clocker and so on as well at the end.
For you guys to hear me?
Oh, hi, Dave.
Oh, hey. Sorry, yeah, I've been on since just about after you started, so
Great.
I didn't think I should just jump in the middle of your talk, but I'm here.
Okay, so yeah, if you want to perhaps explain a bit about Campsite app.
Yeah, sure. So thank you, by the way, for allowing me to share a few words about the app. I'll keep it pretty simple because I know that's not the main topic, but the app is a PHP app with a MySQL backend. Pretty simple, I guess, in the terms of if you're trying to deploy something, it's not there's not like tons of different dependencies, which I think makes this a good app for demonstration purposes. And the application is purpose basically is to help you organize events and groups of people who you want to join your event, and then ultimately the goal of the application is to allow people to share what they're working on during the event. So it's really meant to encourage collaboration at events. Anyway, yeah, it's at campsite.org, and I'm starting to organize some events on it. So it's live now, and it's sort of in the early beta stage. So if anybody's interested and wants to use it, you can. And if you have any suggestions or feedback for us, I would greatly appreciate it.
Okay.
Yeah. Now I could mention a few other things just quickly about the application. We've run it on multiple clouds, and I find that every cloud sort of has these differences between them that make it a little bit complicated to try to run. But yeah, we've deployed it on about 5 different clouds so far, and the real benefit I see with Docker and ultimately Clocker is that you have a consistent endpoint in which you can deploy your application, because even though you might have the same type of host operating system, the way in which the cloud handles things like IP addresses and all that can be very different. So having a sort of a consistent endpoint to deploy your application into, essentially a Docker container, using Docker containers gives you a lot of a benefit. The difficulties that there are today is that you have IP address can still be IP addresses across multiple hosts. So if you have a server, two servers, two physical different servers with multiple containers in each one, coordinating those is quite complex, and so that's where we've found so far Clocker to be very useful. And I guess one last thing to add, before I turn it back over to Andrew, is that the idea is that our application is a software as a service application, but we intend to deploy it on behalf of customers and whoever else wants to download it, I suppose, because ultimately we'll open source it. But if you have an interest in deploying it into multiple locations, having the ability to deploy it on a cloud for a customer on their particular cloud. They may have an account already set up on a cloud. You want to make it easy to be able to deploy into that cloud for them. You don't want to force them to go set up an account on a cloud that they're not using or already paying for. Then this is an ideal option for that. Okay, so I'll hand it back over to you, Andrew.
All right, thanks, Dave. Okay. Okay. So, as Dave said, yeah, the components, it's a simple enough app. It's a PHP web app, a Node API, and a MySQL database, and linking up to various cloud services depending on the configuration. So what we've developed is, I talked about these YAML blueprints, and it's a bit of a cut down version of the full blueprint, so I'm missing some of the extra configuration, but what you can see here is the gist of it. So this is the campsite app. You can see its location, the first item, JClouds, JClouds Cloud API, and that's the HP Cloud Compute location. So that's the JClouds implementation of that HP's OpenStack cloud environment that it's going to use to provision the VMs. And then services, so MySQL node, and obviously in the real blueprint that comes with some extra configuration for some DDL to set up the database. Campsite web app, which is configured with the services it's going to use, so it's going to use AWS for object storage and simple queue service, simple email service. And actually I should have changed those. I'm sorry, Dave, but yeah, we've got the HP cloud versions of those as well. So just to show you, it can use OpenStack versions of these as well. We're not restricted to just AWS there. And then next interesting part of this is the slightly more complex looking database host and port references. Basically that's saying to connect to the database, look up another component, the MySQL component, and find the attribute host.name and mysql.port and inject those into the config for the web app. And that basically is used to link the two services. So they could be, well, when they're running on different virtual machines, obviously the host name is different. The port is your standard MySQL port. If we were deploying this to Clocker, then the host name would be the name of the Docker host, and the port number is going to be the mapped port, the Docker 49XXX mapped port. And in fact, there's similar configuration for Campsite API that I've missed out here. So this blueprint, and I'll show you the more complete one later on when I go to kind of demo briefly the deployment of this. So just to go over the meat of this application, if I go back, you can see there's these brooklyn.campsite.entity, campsite web app, and campsite API, two services that are not MySQL. So these are basically the Brooklyn entities for the PHP part and the Node part, and they control deploying the particular Node packages using npm, installing the various PHP packages for the MySQL client, and all the usual stuff that one would have to do to install a complex app. configuring the virtual hosts for Apache HTTPD for PHP, and all of this stuff is all encapsulated in these two components. And then wrapped together in the campsite application, which is basically a holder for configuration properties that sets up the web app, the API, the Node API, and the MySQL database entities using this YAML blueprint. So, okay, if I flip over to, that's the clustered one. Okay, so we can see here a slightly more complete version of this YAML file with the full configuration for the MySQL node, for the services being used, and so on and so forth. So what I'm going to do is take this, modify the location. In fact, I can't remember what I called it. It was that we could start like this. So it's HP Docker Cloud we want to deploy to. So I could deploy using this catalog entry, but instead what I'm going to show you is HP Docker Cloud. If I select all of this, deploy, and we can simply paste in the YAML here. And you can see this is a very simple application. It's simply 3 nodes, and if I expand everything, we can see the containers already starting up. So it's using the depth first strategy, I should point out, because that's the default. Oh, is it on fire? Okay, so already we have the 4 containers provisioned, and if I go and look at that, I can see that's one for the MySQL node. I can see one for Tomcat, and wait, no, one campsite API, so I've obviously missed one out. Tomcat was the app we already deployed, and this is our campsite web app. So I'm going to leave that starting itself up, and at the same time, I'll show you this using HP US West, and just starting the application in virtual machine, so you can see 3 nodes. And if I show you the activity here, we can see we're provisioning a VM in HP US West. So again, I'm going to leave this to do its thing and start up, and back to the presentation. Okay, so what else can we do now that we have the ability to write blueprints, to deploy them to both an OpenStack or a virtual machine-based environment and to a container-based environment? Well, we can take these three entities and we can turn them into a clustered service, so something a bit more suitable for deploying into production. So rather than just a single host running the web app service, we can put a load balancer in front, in this case Nginx, and behind that a cluster of these PHP web app entities. It's possible because it's a stateless service. All the state is held in the SQL database, so of course we have a point of failure there. We could have created a clustered version of the database as well, and that's again something else that could be done simply by modifying this YAML blueprint. We're not writing any more code. The campsite web app already knows to only run the database creation once. It's designed smart enough to do that, to only run the install step the first time. It doesn't reinstall itself if it's deployed more than once. So we can just use these existing entities, put them together, and in fact, just if I flip back, this blueprint here, if we look, we can see a slightly modified version of that, slightly more complicated, and with affinity rules describing how to place these entities. So we can see that the campsite web app should not have affinity with the Nginx controller. We can see the Nginx controller should not have affinity with the web app or the API, and so on and so forth. So there's extra SSL configuration in here, but we haven't changed any code. We're just bolting together these services, these entity services, in a slightly different way to get a more capable application, more production ready. If I go back here, this is taking its time. It still says starting. Database, what's that doing? Activity in progress. Okay, so we're installing MySQL on one of these Docker nodes here. Yeah, it's still running. You notice in this case that the containers came up very quickly, but because I didn't modify the blueprint that I was using, unfortunately we still have to pay the price to download the MySQL binaries and the campsite binaries and so on and so forth. We can't get away from accessing the network at least once unless I perhaps pre-configured with a Docker image that already had these things available. So because I was reusing an existing blueprint, obviously it had no Docker specific configuration available. With a simpler application like the single Tomcat, obviously that starts up a lot faster, but yeah, and you can see HP on the virtual machine version itself. Yeah, we're actually at the same place, although with, if I look here in progress, and provisioning took a whole 2 minutes, whereas the provisioning for these database apps here is a lot faster. So yeah, seconds to provision these things. So again, I'll leave this running. It's not much fun waiting for things to download and run, and particularly I think the network's quite heavily loaded being in the UK, and I foolishly chose California as the location for the destination cloud. So there's a bit of network travel having to be gone through. While we're waiting for that, I can summarize what we've seen, and then we can have questions while we wait for things to finish, and I can show you the web resources. So Docker containers are incredibly useful. They let us split applications up into microservices, which are very well-defined small components, but there's still limitations to Docker. In particular, running it across multiple hosts requires very careful management of IP addresses, port mappings, and so on. And in fact, there is no native management mechanism. Of course, there's an ecosystem of tools out there springing up, and the one I've talked about, Clocker, is a mechanism for taking application blueprints and orchestrating them across multiple Docker hosts and hence Docker containers. So it's a way of increasing the power and the capability of a Docker deployment and containerizing existing applications that you've described in a certain way and moving them onto Docker in a very, very simple fashion. And as I mentioned, you can find all the stuff that we've been talking about here. Clocker.io will take you to the Clocker GitHub site. Brooklyn.io is of course the Brooklyn Apache Brooklyn page, and there's various other GitHub repos there. I'm sure you know the Docker site, and at the end there's a link. Dave has written an interesting blog post just the other day, yesterday in fact, about exactly this sort of thing and how containers and container management are becoming a problem that we need to solve, and talking about Clocker and the ways it can solve those. So that's essentially it. I mean, if there are any questions, I'm here, Dave's here, and Andrea would also be able to answer any questions about the JCloud side of this, how we managed to use JClouds to talk to Docker and to basically use containers in the same way that we're using virtual machines. So if there are questions or anyone wants to follow up here.
So there are. Thank you very much for your presentation, guys. There are no questions so far, so just in case you have any and you haven't asked yet, please shout out to us via IRC. We are on hash OpenStack pound community. So let's wait another 1 or 2 minutes. If questions pop up, then obviously answer those, and if not, we'll end this session.
Okay.
2 minutes can be very long if you're asking for, if you're waiting for someone to ask questions during a hangout. So let's see.
Have you got it?
Oh, people are leaving RC. Okay, so. All right. So thank you again very much for this session. Thank you everybody who joined us and watched us live. We had up to 50 people in peak times watching our session. In case you were not able to watch the entire session or you want to share it with colleagues, the recorded session will be available in a couple minutes. So thank you all very much, and see you soon.
All right. Thanks for listening. Yeah.